Hello, we're in Chapter 8, Section 2, Multiplying and Dividing Rational Expressions. I always thought that the name of this section was misleading because out of the four things we're going to do, multiplying and dividing are only two of them. One of them is this, where we're going to simplify. And if you saw the introduction video that I just talked about, this is going to look very much the same. The only big difference is, boom, now I've got variables. So we'll see how that goes. And of course, the fourth thing, we'll get to that in a minute. All right. In the last video, the introduction video for this, we talked about taking a fraction. And first, we're going to factor the numerator and the denominator. That's the top and the bottom. Then we talked about what do we do? Cancel, reduce. I'm going to use the word simplify. But of course, that's what I'm doing to the whole thing. And then we're going to re-multiply if I need to. And I'm out of room here. Sorry about that. Okay, that's what I'm going to do with these. What are these? These are rational expressions. What does that mean? A rational expression is a ratio. That's where the word rational comes from. A ratio is a fraction. So this is a fraction. You're going to see fractions in every problem we do in this section. And the next two sections also. A rational expression is an expression that looks like a fraction, and the ones we're going to be doing have variables in them. These have polynomials. So I'll get to that one in a second. But we're still going to follow this step. We're going to factor, we're going to reduce, and of course I'm saying that word kind of like knowing that it's a weird word, and then we're going to remultiply if we can. All right, let's do this one. Start off real easy, okay? So 3x to the 7th means 3 times x times x times x times x times x times x times x. Man, I wish there was a shortcut for doing this. Let's explain it before we talk about shortcuts. 2x to the 4th power is 2 times x times x times x times x. Any factor that is in the top, the numerator, if it shares the same factor in the denominator, like x over x, then that's going to simplify and equal 1. X divided by x equals 1, except for one number, and we're going to talk about that in just a moment. All right. So if that was 5 divided by 5, that equals 1. And all of these right here, x times x times x times x divided by x times x times x times x, those can all be, and I'm using this word specifically telling you that we don't want to use this word, those can be reduced. They can be canceled. All right? So we go, and of course, I like to put circles around them because if you draw lines through them, they're x's. It doesn't make sense. So what's left? Now I'm going to do the remultiplying. What's left? I got 3 times x times x times x. That's 3x to the 2nd power. What's left in the bottom? This is 2 times, and again, keep in mind, all of these, those all equal 1. So this is 3 times 1 times 1 times 1 times 1 times x times x times x. This is 2 times 1 times 1 times 1. So that's just 2. All right. So this is going to simplify from this to that. Oh, excuse me, I made a mistake. I just caught it. I wrote a 2, and I think I said 3, but rewind the tape. Rewind the tape. Sorry about that. It's 1, 2, 3, x to the 3rd power. So pretend I wrote to 3. Okay. So this reduces to that. Like I said, I wonder if there's a shortcut. There is. I have 7 x's here. I have 4 of them here. 7 subtract 4 using my exponent properties is 3. 3 to the x third. But I expanded this. This is called expanded form. I expanded it so that you can see exactly what is happening. I'm in explain how this works mode. I'm not in let's just get the answer mode. The question does say identify any x values, that's what the x could equal, which the expression is undefined. What does that mean? Okay, here's the deal. Division by, that means in the denominator down the bottom, 0 is undefined. So that means that any number that makes the denominator equal to 0 is going to be make the expression undefined. Well, if I go back to the original, the only number that's going to work for that is if x equals 0. Okay? And again, this gets into like a little bit of communication. Communication. I said the only number that makes this work is if I let x equal 0, but I don't want that. That's the one that I don't want. So I say, don't let x equal 0. All right? If x equals 0, if it does, this is going to be undefined. So I know. Sometimes in class I'll be like, all right, well, x equals 0 makes this bad, so x does not equal 0. And sometimes students only hear x equals 0, x doesn't equal 0. Make up your mind. You got to hear the whole thing. Let me say it slowly one more time. If you let x equal 0, this will be undefined. So don't let x equal 0. Now the next one, we're using polynomials. But the rules, the steps are exactly the same. I'm going to factor. I'm factoring a polynomial. Then I'm going to simplify if I have any factor in the top and the bottom that are the same. And then if I got to do any remultiplying, I will. All right, so in the denominator, numerator, I don't care, it doesn't matter which one you start with. I'm going to factor, if I can, and it's going to look like that. What two numbers multiply to give negative 3, but add to give negative 2? That's going to be x subtract 3, x plus 1. Now, the factoring stuff from Algebra 1, we did it in Chapter 5. It's showing up again. It showed up in Chapter 6. It's showing up again in Chapter 8. It's never going to go away. So I will post the links to my Algebra 1 factoring videos. You probably already saw them if you needed help with factoring, but if not, they're there. X squared plus 5x plus 4, what two numbers multiply to give 4, add to give 5? That's going to be x plus 4 times x plus 1. Now check this out. The x plus 1 and the x plus 1, those are the same. Whatever this is, divided by whatever that is, equals the multiplicative identity, which is 1. So this is going to reduce, cancel, simplify. I'm getting kind of tired of explaining the vocabulary. So one thing like the book does, and I've seen teachers do this, and I do it. I don't like doing it. But one thing that we do is we kind of like draw a line through it. And I think that that's bad. But I don't have a better way of doing it. So this becomes, and notice I'm not using any equal signs. I've done no equal signs here. This just becomes x subtract 3 divided by x plus 4. And that's it for the simplifying part. Now I have to decide what's going to make the expression undefined. Well, check out the bottom, and this is why I don't like drawing the line through it. Something times something, if those things equal 0, then my denominator is going to be 0. And remember, I don't want my denominator to be 0. So I don't want x plus 4 to equal 0. I don't want x plus 1 to equal 0. Well, what's going to make x plus 4 equal 0? If I say x equals negative 4, that's going to be 0. So don't let x equal negative 4. Same thing with this one. If I let x equal negative 1, forgot the negative, then this is going to be 0. And again, I know you're looking at the factor form. It works. Same thing over here. If I do negative 4, I get 16 plus 4 is 20. 5 times negative 4 is negative 20. 20 subtract 20 equals 0. I'm dividing by 0. I don't want to do that. You can do the same thing with negative 1. So I say, don't let x equal negative 1. X does not equal negative 4. X does not equal negative 1. All right, we'll do 2 more before this video gets too long. Now I've got these complicated ones. All right. So let's see if I can factor this. I got to use my diamond method. So I got 6 times 2, which is 12, 7. What two numbers multiply to give 12? Add to give 7. That's going to be 3 and 4. I make my multiplication chart. I got 6x squared, 3x, 4x, and 2. I'm doing the one on the top. When I factor, I get 3x and 2x and 1, and this is going to be 2. So my factors in the top are 3x plus 2 times 2x plus 1. Now I can do the same thing with, and by the way, this is, I can do this on a scratch paper or something, okay? I just need to get the factors. I'm gonna do the same thing with the polynomial in the denominator. Do my diamond, 6 times negative 6 is negative 36, and they're gonna add to negative 5. I go through my, sorry, I had to grab my computer real quick. I go through my list, I get negative 9 and positive 4. So I make my multiplication chart again. Again, I'm doing this one, 6x squared, negative 9x, 4x, and negative 6. So this will be 3x and 2x subtract 3. And what do these two have in common? They both have 2. 2 times 2x is 4x. Okay, that's right. So this is going to be 3x plus 2. That's nice. Those are the same. Times 2x subtract 3. So however you factor it, I don't care. You can go straight to the factored form. The 3x plus 2 and the 3x plus 2, both of these are going to, when I take 3x plus 2 divided by 3x plus 2, that's going to equal 1. And I get 2x, I don't know why I wrote that, 2x plus 1 divided by 2x subtract 3. Now, one thing that people are going to want to do is say, oh, that's negative 1/3 because the 2x's. No, 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 no. This 3x plus 2, those reduce because you're multiplying, all right? If I go back to like the first paper I showed you, why does the 2 over 2 reduce? Because 2 divided by 2 equals 1, and I'm multiplying by 1. But that's not what's happening with this over here. I'm not multiplying 2x times 1, I'm adding 1. So for one thing that I do, and I don't know if I'm going to do it in the video, you can do it. One thing I do in class is we say, okay, if this did equal negative 1/3, then pick a number. If you do x equals 0, yeah, it's going to be negative 1/3, but try something else. All right, try 100. 2 times 100 plus 1 is 201. 2 times 100 subtract 3 is 197. That does not reduce to negative 1/3. So we kind of like do it by like, you know, putting some x's in there, putting some values in for x and doing it. You can try that for yourself. But this does not reduce. Let me write this. This is not negative 1/3. So remember that. I have to do one more thing before I do the next problem. What's going to make the denominator equal to 0? Okay, so now this is just my scratch work. If I do 3x plus 2 equals 0, I get 3x equals negative 2, I get x equals negative 2/3. If I let x equal negative 2/3, this is going to be 0, which makes this 0. So don't let x equal negative 2/3. I don't want that. That's the one that I don't want. Same thing over here, 2x subtract 3. If that equals 0, this whole thing will be 0 and it'll be undefined. So that would be 2x equals 3. Divide by 2, I get x equals 3/2. I don't want that to equal. So x does not equal negative 2/3, and x does not equal 3/2. Excuse me. All right, last one. 3x plus 4, that does not factor. That's just going to be 3x plus 4. The only way it could factor as a binomial is if it was a difference of two squares. It's not. That's a square, but nothing else is, and that's not even a difference. Or if there was a common factor, the GCF. There isn't one. So I'm just going to leave that 3x plus 4. For the other one, I'm going to factor, but guess what? if this works, one of the factors has to be 3x plus 4. So yeah, you can do your diamond method. That's fine. Perfectly okay. But I'm just going to show you a different way to think about it. So if I had one of the factors was 3x and 4, and I knew this was 3x squared, I knew this was negative 4. Okay? I don't know what these two are, but I know they add up to positive 1x. So what goes up here? 3x times x equals 3x squared. What goes up here? 4 times negative 1 equals negative 4. So what goes in these two boxes? Negative 3x and 4x. And is it true that 4x plus negative 3x equals positive 1x? Yeah. So what I'm kind of doing is I'm doing kind of like a modified area model. I'm actually dividing, all right? So I'm seeing if 3x squared plus x subtract 4 divided by 3x plus 4. And you could, to be honest, you could have used synthetic division now that I say the word dividing. Oh, excuse me. No, you couldn't have because of the 3. Sorry about that. I meant to say long division. You could have used long division. Okay? But it does, using the area model, it looks like I get 3x plus 4. Those are going to simplify times the other part, which is x minus 1. Now I know that the 3x plus 4 and 3x plus 4 are going to go poof. That's going to give me the x subtract 1 in the denominator. But what gets left behind? I took everything out of the top. No, you didn't. You can always multiply by 1. So it's 1 over x subtract 1. All right, last thing I need to check, what's going to make this go to 0? So if 3x plus 4 equals 0, which I don't want, I'm going to get 3x equals negative 4, and I'm going to get x equals negative 4 thirds. But I don't want that, so say it doesn't equal that. I don't want that to equal. X does not equal negative 4 thirds, because if it did, this will go to 0. And the other part, x minus 1 equals, or I don't even know if you need to write that out, x cannot equal positive 1. Okay, in the next video, we're going to do the exact same thing, except sometimes you have to make things work by factoring out negative 1. We'll see you there.